Hello, everyone. Good morning, afternoon, evening. Uh, just a second. Yes. Dear authors and invited guests, welcome to Technical Session 6G. Myself, Priyanshi Goyal, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 9th International Conference on Information and Communication Technology for Intelligent Systems, ICTIS 2025, Bangkok, Thailand. The 9th edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in Bangkok, Thailand, and the virtual event is being held through Zoom today and tomorrow, that is 5th and 6th of April 2025. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for question and answers. On 9 minutes, I'll raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any queries or update, then you can write it to me in the chat box. Just before we start the session, I would like to introduce you all to the chair for this session, Dr. Ajay Kumar Sharma. Dr. Ajay Kumar Sharma is working as an associate professor and MTech coordinator in the Department of CSE at GITS Udaipur, Rajasthan, having teaching experience of more than 18 years. He has presented a number of papers in national and international journals, conferences, and symposiums. He has also reviewed more than 15 papers in IEEE and Scopus Index conferences and journals. We're glad to have you here with us, sir. Now, I would like to invite the session chair, Dr. Ajay Kumar Sharma, to deliver the welcome remark and set the tone for the session. Over to you, sir.
Hello.
Yes, sir.
Audible?
Yes, sir.
Thank you. Thank you. I am the session chair for that. Really, especially thanks to Amit Joshi sir and you also. And I think the total papers are, I think 10 papers, huh?
Yes, sir.
All the guidelines are given by you. So
Yes, sir.
we can start and you can start.
All right.
Thank you.
Thank you so much, sir. With that, let's begin the session. I would now like to invite, sorry. I would now like to, I'm sorry, uh, introduce the second session for the chair, Professor Sarita Gajanan Rathod. She's an assistant professor at KJ Somaiya Institute of Engineering and Information Technology, India. With a strong academic background, she is dedicated to teaching and research in engineering and information technology. Her expertise lies in fostering student learning through innovative teaching methodologies and contributing to advancements in the field. I would now like to invite Sarita ma'am to to deliver the welcome remark and set the tone for the session. Do we have you here with us, ma'am? You're not audible, ma'am. No, ma'am. You're not audible. Is anybody else able to hear her? I think there's some technical error on ma'am's side. So we will be moving forward for the time being. Now calling the first presenter for the session, Priya Singh. I invite Priya Singh to kindly present her paper titled Design and Simulation of Wideband Low Power Inverter Based Local Feedback Transimpedance Amplifier using Negative Capacitance Technique. Do we have you here with us, Priya?
Yes, ma'am.
All right, I'll stop presenting so that you can share your screen.
Yeah, okay. Is it visible, ma'am?
Yeah.
Yes, it's visible. You may start.
Hi, good morning and good afternoon to all present over here. I'm Dr. Priya Singh, and I'll be presenting in 9th International Conference Information and Communication Technology for Intelligent System. And my topic is design and simulation of wideband low power inverter-based local feedback transimpedance amplifier. In this, we have used a negative capacitance technique. So the authors for this paper is me, Dr. Priya Singh, then Dr. Indu K, Mr. Jayaprakash S, and Dr. Arya Lakshmi BN. So we are faculties in Bangalore, India, assistant professor. Here, the content of the presentation will be first the introduction to TIA, that is trans impedance amplifier, then the various techniques, the two most important techniques which we have used for increasing the bandwidth, then the proposed circuit, the results in the comparison with previous work. So here, first thing to know is what is trans impedance amplifier. So in our communication system in receiver side, basically this trans impedance amplifier will be used to convert the detected signal from current signal to voltage signal, that too in amplified way. So basically we have many types of transimpedance amplifier. We have many different configuration, but mostly we will be using the regulated gate cascade transimpedance amplifier because it have better chances of higher bandwidth and it is mostly commercially used. So now in my design, we have used the negative capacitance method. So because of which we have obtained the high bandwidth of 8.5 gigahertz and gain obtained is 61 dB and with very less power consumption of 4.2 megawatt. So here are the two techniques, negative capacitance, that is figure A, and then capacitive degeneration techniques, figure B. So these two are just the example figure for explaining what is the negative capacitance and capacitive degeneration technique. So first we'll go for figure A. In this, our capacitor C1 will act as a negative capacitance, and because of, capacitor C will act as negative capacitance. So here we are connecting it in positive feedback, but because of this, our dominant pole will shift and thus our bandwidth can increase. Now, similarly, in this capacitive degeneration technique, in figure B, the CS will act as the capacitive degeneration capacitor, and because of this, an extra zero will be added in our circuit so that our bandwidth can be increased, and the dominant pole, if there is any dominant pole which is in a lower range of frequency, because of which our bandwidth can be reduced, it will cancel by introducing that zero. So this is our proposed diagram for transimpedance amplifier. Here our MN1 will act as the main amplifier and MP1 it will act as a load resistor. And this MP2 and MN2, they act as inverter, and this inverter will be used as feedback to improve the gain for the whole amplifier circuit. And here MN3 will also act as the final output stage for amplification. Here we have this C1, as you all can see, this C1 will act as the capacitor which will act as both the negative capacitance and capacitive degeneration. So here we'll be having the Miller capacitance effect, because of which at input side it will act as negative capacitance and at output side it will act as capacitive degeneration. So we'll be increasing the bandwidth by cancelling the dominant pole which is already present by introducing a zero, and then introducing one extra pole that will increase the bandwidth. So after designing and simulating the whole schematic, the first thing we did was to know how much gain we are getting by the AC analysis, that is the frequency response for our circuit. So from this we can see that we have obtained the gain of 61 dB ohm with the bandwidth of 8.5 gigahertz. Next, we had tried varying the capacitor value from 250 picofarad to 450 picofarad, and we can see the variation is as we are increasing the value to 450 picofarad. Somewhat our bandwidth will be reducing, although the range is not much high, but somewhat more deviation will be there. So standard what value we have taken for this capacitor is 250 picofarad. Then after changing the temperature also, we were trying to obtain what will be the result on our circuit if you are changing the temperature for our IC. Then the temperature variation was from 25 to 110, and as we can see, our gain is less in lower temperature, and in higher temperature, in fact, our gain is high. So what we have claimed is 61 dB only. So even if the temperature is increasing, our gain won't be reduced for our IC. Then we had done the noise analysis, and in our specified range of bandwidth, the noise obtained was 26.4 picoampere per square hertz. And then we had done how much eye diagram we had taken to see what is the total range in which it can pass and how much window it is getting with noise also. And here we have the wide opening in our eye diagram, so noise effect won't be much for our IC. Then we had done the Monte Carlo simulation for our circuit for the gain. Here we had taken 1000 samples, and the deviation was of 0.2 dB ohm only, and maximum gain which we have obtained was 61.2 dB ohm. Then we had designed the layout for our IC. As we can see, we have a design layout here, and then we had done the pre and post layout simulation. And here, very minimum deviation is there in terms of bandwidth, as we can see, and gain is not affected much if we are doing the post and pre layout comparison. Then after this, we had compared with some previous work done or some modification done in RGC. Then after including the inverter type of feedback, so our proposed TIA, so actually we had focused to compare it with 180 nanometer technology only, because that is what we were using, and our supply voltage was of 1.8 volt. After this, we have obtained the gain of 61 dB ohm, bandwidth 8.5, which is high as compared to others which we have studied till now, and power is very less, that is 4.2 milliwatt. Noise is also comparatively optimized, although we have one circuit in which less noise is there. Then if we consider the figure of merit including all the parameters, then we are getting the high figure of merit for our IC. So we can conclude that our work, which we had made in 180 nanometer CMOS technology using Cadence Virtuoso tool, we are obtaining the high bandwidth of nearly 8.2, which can be extended till 10 GB per second. And it is an inverter-based local feedback topology, which we have used basically so that we can get the high bandwidth. We have reduced the power consumption to 4.2, and the bandwidth which we are obtaining is 8.5 gigahertz. Hence, the results are optimized, and further we can do the conversion to proper chip and check the final thing. These were the references which we have seen. So this is it. Thank you.
Thank you, Dr. Priya. Are there any questions?
Dr. Priya, nice presentation, Anna.
Thank you, sir.
Tell me, what are the typical applications of TAI?
So basically it can be used in communication system or any other system which is using any sensor to detect a signal. Like it can be used in military applications also, biomedical applications also. But the thing is, mainly we had focused in communication, so we were achieving for the gigahertz bandwidth. But if we will go for the medical applications where some sensors are used to detect a signal, so mostly your signals sensors will give the signals in the form of current, and most of our other processing blocks will be voltage domain. So it can be used anywhere, wherever we are detecting the signal.
Okay. And tell me, what are the key performance parameter of TAI?
So key performance parameter is it should most important thing is it should have high gain. It should have low input impedance and low output impedance, because at input side we have current and output side we have voltage, and then obviously noise should be low, and the bandwidth should be high for the, I mean, application specific. If
Yeah.
that's it, sir.
Why you choose specially an inverter-based architecture for TAI?
Sir, till now I have seen that when the in feedback mostly they were using common source type of amplifier, but there is certain limitation we can if we go numerically, then yeah, our gain is inversely proportional to this bandwidth is inversely proportional to the gain. I mean, there is always a compromise between the two. So when we are using the common source type of feedback, so it was limited, we were not able to increase more. So that is the area where we thought of, instead of using the common source, we can use some different type of amplifier as a feedback. So there we used the inverter type, because
Okay.
its gain is
Uh,
not limited.
yeah. I think one more question is that we want to improve the bandwidth improvement. Okay.
Yes, sir. Yes.
How negative capacitance technique helped?
So this negative capacitance technique, actually, it will include one more dominant pole. I mean, a pole which will be higher than the dominant pole which was earlier present. So because of that dominant pole, its bandwidth will increase.
Any simulation tool you use?
So cadence virtuoso.
Okay. Thank you.
Oh, thank you, sir.
Thank you so much, Dr. Priya.
Thank you, ma'am. Can I stop?
Yes.
Okay.
Moving forward, I would like to invite Makardhwaj Kamble to kindly present his paper titled Enhanced Safety and Connectivity, Exploring IoT Integrated Smart Helmet Systems. Do we have you here with us, Makardhwaj?
Yes, good morning.
Morning.
Good morning.
Just a second. I'll stop presenting. Yes, you can present now.
Is my screen visible?
Yes, your screen is visible. You may start.
Okay, good morning, everyone. Title of my paper is Enhanced Safety and Communicating, Exploring IoT Integrated Smart Helmet Systems. So, authors are Professor Atul Pawar, Ashwini Harode, Makardhwaj Kamble, Mrunal Jadhav, Sanskruti Kadnor, and Aishwarya Mukherjee. These are from Pimpri Chinchwad College of Engineering, Pune, India. Aishwarya is actually a pass out and she's currently working in Amazon, California, USA. Introduction. So background, road safety for two-wheeler riders or bikers is a major concern worldwide. Motorcycle accidents often lead to severe injuries or death sometimes due to delayed emergency responses. So, an IoT smart helmet can enhance safety by detecting accidents in real time and triggering the emergency alerts. Our objective is to propose a conceptual framework for an IoT-enabled smart helmet that improves accident detection and emergency communication for the bikers. The problem statement. First is safety risk. Two-wheeler riders are at higher risk due to accident and absence of real-time alert mechanism or a safety net. Uh, a traditional helmet provides safety till the accident occurs. Then what about the post-accident safety net or two-wheeler rider will require? They and the limitation of traditional helmets are they only offer passive protection and without any active monitoring for emergency response feature. There is a need for innovation, a system that actively detects accidents and promptly communicates the rider's location and critical information if essential. Proposed solution and methodologies. And IoT-enabled smart helmet framework that integrates key components to enhance biker safety. So the core component include a microcontroller. For example, we can use ESP32 sensor. We can use a piezo shock sensor that detects collision. Uh, we can uh, we can add a threshold to that sensor. Uh, the sensor triggers the event only after that certain threshold. Third, we have a false alarm. Even if the accident is minor and the trigger is triggered, there will be a false alarm switch, allowing the rider to cancel the alert for minor impacts. Then communication model you will be used Bluetooth and GPS and GSM. A GPS will be used for determining the rider's location and GSM for communicating. Proposed solution. First, the system flow. The sensor detects an impact. The microcontroller processes the data. A warning is issued to rider, so he can, if he doesn't cancel that warning within a time frame, let's say 1 or 2 minutes, then the emergency alert will be sent to emergency services, and that will be done using GSM and GPS and Bluetooth framework design. So for data flow is like this. The first there is a detection phase that impact sensor captures sudden shocks. Second is processing. Data is processed by the microcontroller. Third is user interaction. The helmet warns the rider and awaits a response. Fourth is emergency response. In absence of response, the helmet uses GPS to obtain the location and Bluetooth and GSM to alert emergency contacts and services. For future scope, we can also add the optional medical profile of the rider. We can transmit the data like blood group and any other allergies he has. And the communication part will be wireless using GSM module. This is a simple flow diagram, you can say. Here we have impact sensor, control unit, a Bluetooth module, a GPS module, and a false alarm switch. It will First, we will pair the smart helmet to smartphone. This can be used to send location to emergency services and notify the emergency contacts and dispatch the assistance. Result and analysis. We expect to reduce the time, even if it is by minutes, to riders or two-wheeler bikers to get help after the accident and enhance their safety through active accident detection. Analysis based on theoretical evaluation and simulations. The framework shows promise in improvising real-time communication and safety outcomes. So challenge and limitations this can face is sensor accuracy, ensuring reliable calibration of impact sensors. Second is connectivity. Depending on the network coverage area, let's say the accident happened in a very remote area or ghat or something. So the coverage can be a limitation. Third, power management. Optimizing the battery of that microcontroller and sensors can be tricky, and a person might need to charge their helmet time to time. And this is still in a prototype stage or a conceptual idea, and real world testing is pending. Future scope, first is a prototype development. We can make a we can make a working model and test on real world scenarios. Second is system refinement, improving sensor calibration and connectivity issues. Extended features, potential integration of additional data, like I said, like medical details and uh, mobile app in future to create a medical profile of that person. Third is border application, like future research could explore future integration with mobile application and emergency systems. In conclusion, the proposed IoT-enabled smart helmet framework outlines a system capable of detecting accident, providing immediate emergency alert, and potentially transmitting critical rider information. The impact this conceptual design offers a pathway towards significantly enhancing biker safety. Uh, Next step, focusing on prototyping and rigorous testing to validate the framework effectiveness. Thank you.
Thank you.
Nice
Are there any
presentation.
questions?
Nice presentation, I think.
Thank you, sir.
Tell me, one question is that, uh, what are the core objective of your smart helmet system?
So core objective is, sir, let's say an accident occurs, and if we can uh, notify the emergency services like ambulance and whatever nearby hospital few minutes earlier, it can save a life, or it can uh, avoid that injury being a very fatal injury. So our core objective is safety after accident, like post-accident safety net.
Then what is the role of IoT in your smart helmet?
Okay, so to detect the impact, to transmit the location, we are using sensors and a microcontroller. So we that comes under IoT.
Uh, how the data transmitted from helmet to other devices or server?
Okay, so this is just a conceptual, but we have two main ideas. First is a GPS and GSM module. What a GSM module can do is uh, hook up to a mobile network and transmit data by that, or we can use Bluetooth and get permission from smartphone, and we can send uh, all the location and required data from smartphone itself. But we will need to develop a mobile application and uh, whole other backend. So we have two ways.
Did you implement real-time monitoring?
We did not make an prototype, but we experimented using only uh, sensors and the controller.
What type of sensor are you using?
Piezo shock sensor.
Okay.
Also, it is a very cost effective. If we decided to further make a prototype, it will be a very cost effective prototype or a product, because in India, I think there are people who are not willing to, what you can say, spend more money on such things like helmets. There are barely people who wear helmets daily. So our another goal is to make it cost effective.
You are using microcontroller ESP32, no?
It has
Why?
inbuilt Bluetooth and Wi-Fi.
Tell me how helmet ensure that only rider can activate or deactivate features.
Okay, let's say um, uh, a helmet detects accident or event occurs. So you are asking about the false switch, right?
Yeah.
Okay, then upon accident also, he will have a time frame of 1 to 2 minutes. If the accident occurred, but rider is okay, he is confident that he doesn't need any assistance. There is a false switch. We can create a physical switch upon a bike or by smartphone, or we can create a physical switch in the helmet itself to cancel that alert. That is it.
Tell me, if you are commercialize your product helmet,
Hmm.
what steps you taken next?
To commercialize, first of all, sir, our next goal is to create a working prototype.
Okay.
So commercializing is a way
Yeah.
forwarding future. So we have not
Any
thought about it.
okay. Any challenge you face in testing or
Yes, sir. Let's say we have multiple sensors, right? And we have to calibrate it. And one sensor is detecting above threshold, another sensor is not detecting. So the communication between sensors and control can be a challenge. We need to work on that, but it is doable, and we think we can do this.
Can a rider receive calls, messages, or navigation updates through helmet?
If we add a Bluetooth modem with a mic and a speaker, like some of the helmet already in market have, yes, he can receive calls and messages.
Okay, nice, and thank you.
Thank you.
Thank you so much, Ajay sir. Thank you so much, Makaraj. Before moving forward, I would like to request Sarita ma'am to, I think she's here with us, to kindly give a remark and ask any questions she has for the sessions. There's still a mic issue at your end, ma'am. Like I'm not able to hear
My
you.
mic is not working, I think.
Yeah.
I think mic is not working.
No, ma'am, not able to hear. Uh, is it okay if I move forward?
Yeah. Okay.
Okay. All right. All right. Moving forward to the next presenter, I would like to invite Juljalal Al-Mamur Sayed to kindly present his paper titled IoT-based mobile application for real-time localized weather monitoring and forecasting with incremental learning. Do we have you here with us?
Yes, I'm
Right.
present
I'll
right now.
just stop presenting. Yes, you can present your.
Thank you. Am I visible?
Yes, yes, it's visible.
Okay, thank you.
Can you please put it in presentation mode? Yes. All right, you may start.
Okay, thank you. Hello, I think I'm clearly audible. Thank you for giving me the floor for presenting our work. I am Juljalal Al-Mahmoud Shayur, the first author and the presenter of our work titled IoT-based mobile application for real-time localized weather monitoring and forecasting with incremental learning. Let us start. Let us. Sorry, I am having an issue with. Okay, let us start with the introduction. Importance of weather forecasting is one of the major requirement of today's life. Accurate weather forecasting is crucial for daily life, safety, and decision making across industries. However, most existing weather apps rely on distant weather stations, leading to inaccurate local forecasting. Our solution is a real-time weather forecasting mobile application that integrates IoT sensors and incremental machine learning models. These sensors collect real-time environmental data, while our incremental model continuously improves prediction accuracy. Our initial implementation was in Gazipur, Bangladesh, demonstrates its effectiveness, and we aim to extend nationwide to enhance weather prediction, reliability, and usability. Now let us discuss about the problems. Accurate weather forecasting is crucial for daily decision making, yet existing systems face several challenges that limit their effectiveness. Some of the problems that we have focused that with existing solutions that inaccurate local forecasts, lack of real-time data, limited IoT integration, non-incremental machine learning models, inefficient APIs and database integration, scalability issues, high cost, and poor mobile interface, reducing ease of use. And now I am going to discuss about some of the major contributions of our paper. To address the limitations of existing weather forecasting systems, our work introduces several key innovations like real-time weather updates, incremental machine learning model, uses a seamless API integration, scalable systems through which we can expand our system throughout a broader geographical area, which must be scalable. And it is obviously a cost-effective solution and user-friendly solution. With this contribution, our systems not only improves forecasting accuracies, but also enhances accessibility, efficiency, and scalability, making real-time weather forecasting insights available to all. Here is a basic working flow of our work. First of all, we have collected our precise weather data of our locality using authentic website called Visual Crossing. Here we took almost 24 years of data and we stored them in a database. Before storing them, we have done some pre-processing like level encoding, drop some unused columns, as there were a huge number of columns. All of those were not important for our model. And then we have used various supervised learning models like decision tree, KNNs, linear regressions. And we found that random forest is performing better in this case. And then we have set that model in our backend, through which by using API, we retrieve those data in our mobile application, through which we can get real-time data, which we get from the IoT sensor and IoT sensors, which we send in our database. And here we can, from this page, we can select a date and get forecasting of weather information. Here is the hardware setup. It's a functional prototype. It's not an operational prototype. So here we have used various sensors like DHT21, LDR, rain sensor, BMP 180 for barometric pressure sensor, and anemometer for wind speed. As microcontroller, we have used Arduino Uno, and for communication, we have used Ethernet Shield. And then we have used various APIs to send data to mobile application. Here is the activity flow of our front end. That means our mobile application. We have a login and sign up page, and then this is the main page where we can get view real-time weather data, and we can get various graphical representation like line chart for real-time data, and we get prediction table here. And for additional feature, we have added location, share, and rating options, and from where we can get a precise location and other settings are there. We have also developed a dark mode, which, and for result and discussion, we have concluded 4 of the best performing model. Among those, random forest regression performed better than other models. We can see that MAC, MAE, and RMAC values are lower here. And if we look at these graphs, that the predicted values and actual values are almost similar. The deviation is very little for almost every elements of weather, like humidity and temperature and so on. So the main question is why we have proposing to use incremental learning model. We use an incremental learning model because as more data comes or have become available, the model continuously learns and improves prediction accuracy. Unlike traditional models that requires retraining from scratch, incremental learning updates the model efficiently without losing previous knowledge. Our result shows that with an increase in training data, performance metrics like MAC, MAE, and RMAC improve significantly, making our weather forecasting systems more reliable over time. Through this, using this graph, we can see with the increment of the data, the performance, the errors, MAC, MAE, or RMAC is decreasing. That means our the performance of the model is increasing. Here is the flow diagram, how we have deployed actually our incremental model. Here are some of the snapshots of our front page. Here is the login page, sign up page, and we have used various validations to ensure authorized login or access to the system. We have used OTP verification through email. And here is the main homepage from where we can get the real-time weather data. Like we can get the temperature, humidity, light intensity, air pressure, wind speed, and raining condition. And we get a precise summary here. And from this table, we can get the forecasting of coming 3 days. Like we have show here average temperature, pressure, and humidity for coming days. And here is a graphical representation of the wind speed. And we here we can say with the time the wind speed deviates. And from this, we can select the date we want to get forecasting information. Here is the location, rating, and other features of our weather application. And we have also used a time sensitive dark mode. For night time, this will occur dark. And here is the estimated cost, which is calculated in Bangladeshi taka. The overall cost is 18,000 and something more for hardware deployment, which is near $180 in US currency. And for conclude, while our system provides accurate and real-time weather forecasting, there are still some limitations, such as limited geographic coverage, dependencies on sensors accuracy, and data privacy concerns. To address these, we plan to deploy more weather stations across various locations to improve localized forecast. Continuous real-time data collection will further enhance our model's accuracy, and we aim to develop advanced machine learning models using localized data for even better predictions. Additionally, we will refine our model or mobile application with new features based on user feedback to improve accessibility and functionality. With this advancement, our system will become more reliable, scalable, and impactful in delivering precise weather forecasting. So this was it. Thank you for having me.
Sister, your nice presentation.
Thank you, sir.
Question is that how your system different from the traditional weather forecasting platform?
Okay, sir. Unlike Google or like something or like similar weather forecasting systems that rely on distant weather stations, our systems uses real-time data from localized IoT sensors, ensuring more precise and localized location-specific forecast, which is really helpful for agriculture. Additionally, our incremental learning model continuously improves its accuracy, while most existing apps use static models. And our solution is more cost-effective than those as we have used localized systems and IoT hardware for targeted regions.
Then tell me what sensor you use in your IoT setup.
So basically, we are using 5 sensors. They first of all, we have used DHT sensor, DHT21 for temperature and humidity, and then we have used LDR for light intensity, the rain sensor for rain presence, detecting rain presence, and BMP 180 for barometric pressure sensor, which gives values of air pressure, and we have used anemometer for wind speed calculation.
How you collect and transmit sensor data?
First of all, sir, we collect these data from our sensors. I have mentioned the name of the sensors, and those sensors are connected with our Arduino Uno, and using an Ethernet shield, we send the data through the internet to our local host.
Then what platform you use to build a mobile app?
I actually use Android Studio and Flutter framework, sir.
Do you use any cloud platform?
No, sir. Right now, we didn't use any cloud platform. We use Fast API for communicating.
Any communication protocol you use?
Wi-Fi, sir.
Oh, Wi-Fi. Okay. And what parameter are you using for tracking the weather forecasting?
Sorry, sir. Can you please elaborate the question?
What parameter are you using for tracking the weather forecasting?
Okay, sir. The parameters are actually we are taking 11 weather parameters from the data set. Like we collect the humidity information, we collect the rain information, the barometric pressures, airs, light intensity, and we show these parameters for forecasting, sir.
Why you specially use incremental learning?
Yes, basically the base data set that we are using is not that much large, as the data are paid. So we only collect 24 years of data, and we deploy incremental learning that with the time this model will enhance. In our results section, I have shown that with the increment of data, the performance of the model is increasing. So incremental learning helps us to add more data and gaining better results without training the model from the beginning. Just new data comes and the performance is increased with the increment of the data.
Okay. Then how you test your sensor and forecasting model?
So we have deployed in our locality, in our campus, which is situated in Dhaka, near Dhaka, and from real-time weather information, we have developed this.
Any technical challenge you encountered?
Yeah, the major technical challenge was to integrate these sensors and send the data over Wi-Fi. If the network is not stable, then the system face difficulties to send data, and it becomes very hard to retrieve data. Apart from this, we are targeting to use LoRa for long-range communications. These are the sort of main challenges that we have faced in our weather.
Thank you.
Thank you very much, sir.
Thank you, Ajay sir. Thank you, sir. Do we have Sarita ma'am with us now?
Hello, ma'am. Is I audible now?
Yes, ma'am, you're audible.
Yeah. Thank you. Thank you
Good.
so much. Because of some technical issue, I was not able to turn on with my mic. Thank you for inviting me for the this conference as a session chair. The presentation of this Jul Jalal was very nice, and the topic which you have been given as which you have been presented here was very nice. My question is only one that the whatever data you have been getting it from your sensors, like how we can check with the validity of that data, like whatever data you have been getting it is proper or not.
Yes, ma'am. For this, before deploying, we have tested each sensor separately with precise sensors. Like we are using some cost-effective sensors, but from our lab where the sensors are more accurate. So we tested those data with our data with that sensor data, and we get almost similar data. Some minor deviations were there, like in temperature we get 32 and the precise sense temperature was 31 or 31 point something.
Yeah. Okay. Fine. So, and one more question is there, is this your application is only mobile application or it is web application also?
So, ma'am, till date, we have only developed mobile applications, but we are planning to deploy it in any in web platforms.
Okay, fine. Nice. Thank you so much.
Thank you, ma'am.
Thank you so much, ma'am.
Thank you.
Moving forward, I would like to invite Shalini Muskula to kindly present her paper titled Leveraging ML to Measure Similarity Between Questions and Answers. Do we have you here with us, Shalini?
Yeah.
All right, I'll just stop presenting. Yes. Yes, your screen is visible. You may present now.
Yeah. So our paper is titled Leveraging ML to Measure Similarity Between Question and Answers. So the authors are Vasavi, Rauri, Jayashree, Shalini, Janavi, and Jayashree. So the problem statement is there are various question answering platforms such as Quora, Stack Overflow, or Reddit, where users will post their queries and other users, which are part of the community, will be responding with answers. But if we see the queries, there are duplicate questions by the users. They might have phrased it differently, but the questions might mean the same. So for which users are giving the answers. So we are trying to gather all the duplicate questions and then summarize the answers of all these duplicate questions and provide a concise summary to the user. So the proposed system aims to detect similarity among the questions in the database, then gather the answers which are duplicates, like the questions which are duplicates, and then summarize these answers into a single answer. So the data sets which we used were Quora question pairs dataset. This is officially given by Quora. And we trained our duplicate question detection model on this dataset. Then for generating the answers for duplicate questions, we used another data set, which is Quora question answer pair data set. So this is our system architecture, where we'll be collecting questions and answers from databases like Quora. Then first step is pre-processing the data, removing the punctuation, etc. Then we will be feeding that to our duplicate question detection model, where the duplicate questions are detected. One, we will be using a sentence bird model. We are using this model because it will even take the semantics into consideration, like it will take the context of the words, and then we will use cosine similarity in order to detect the duplication between the questions. After detecting the duplicate questions, we will be sending the answers of these duplicate questions to the summarization module. In the summarization module, we are using three algorithms, BM25, K-means, and text rank, which will be used to produce the final summary. So first, the implementation involves pre-processing the text, removing extra spaces, and converting into lowercase. Then the second is duplicate detection. So as I said before, we are using sentence BERT model to convert these questions into vector embeddings. Now this model is more accurate because it takes into consideration the context as well. For example, this is a river bank and this is a financial bank. It takes into context the meaning of the bank by checking the words on the left and right. And we will be computing the similarity between the questions by using cosine similarity after conversion into vector embeddings. So if the similarity exceeds a threshold of 0.7, we will flag them as duplicates. Then these are the metrics for the duplicate detection model. We split the training and testing data set in the ratio of 80:2. And this is the accuracy, precision, recall, and M1 score, along with the confusion matrix. So this is an example where the user gave an input, how is an Indian economy? Then the duplicate questions were detected and the top similar questions which were in the data set were given as the result. Then the final part is the summarization module. So right now the answers which we have are the answers of the duplicate questions. We will try to rank these answers based on the relevance to the query given by the user. For that, we are using BM25 ranking. Once we rank these answers according to BM25 ranking, then we will select top N answers and then make them into clusters. So we are using clustering algorithm because this gives different perspectives as to what one user has a perspective on that answer, other user might have different perspective. So all of these are clustered into some N clusters. And then finally, from each cluster, X-rank algorithm is applied and one sentence is taken, so that the summary will have all the viewpoints and the important sentence in that cluster. This is an example for that. So this is the consolidated summary after applying text rank as well. And as we can see, the consolidated summary right now is huge. And this is one of our limitations. One thing is we can't verify if the summarization is actually the summary of the important and relevant information, which seems to be a major issue with the summarization part. And cross-language support. Right now, our model is trained on English embeddings, and we need to use a different model in case of multilingual support. And the current summary extracts the most important sentences from the clusters. It does not combine them and give the user an abstract answer. Instead, it gives the important points and facts. So to overcome this, we will be providing the link beside the answer so that the user knows from this question, this answer came, they can review if they need it further. So that's it. Any questions?
Nice presentation, Shalini.
Thank you.
Tell me, is your paper be applied in real world scenario?
Yeah, so for it to be applied in real world, we'll need to be collaborating with these major platforms such as Quora or Reddit because we don't have access to their database. We have access to only the database which they provided 3 to 4 years ago, that too only Quora. So in order to employ the system, we'll need to collaborate with them.
How you handle stop word, stemmings?
Can you repeat your question?
How you handle stop word, stemming, laminating?
That is done in pre-processing only. It is most like we are removing the tokens there.
Okay. Have you used machine learning model or deep learning model?
Yeah, we use sentence word model.
Okay.
Should I?
Any matrices you use to evaluate similarities?
Can you repeat once?
Any matrices did you use to evaluate similarities?
To evaluate similarities.
Yeah.
Yeah, we first dataset which we used had duplicate questions and a column which said it is duplicate or not. So we used that dataset to evaluate our model first. Then we used another dataset which had questions and answers to produce the answer. And
Have you tried for fine-tuning technique to improve accuracy?
so the accuracy was good because if I were to use other models, not this one, the other one would work on this data, but I don't think it will be working good on the unseen data. This one took the context as well. That's why.
How you handle ambiguity?
As in,
How you handle ambiguity? Maybe multiple correct answers, maybe there.
there might be multiple answers.
Yeah.
Yeah, we are taking that into consideration. So if two questions are similar, let's say if n questions are similar, we'll be collecting the answers of all the n questions. Then summarize these n answers.
Okay. Nice. Thank you.
Hello.
Yeah,
Nice presentation, Shalini.
thank you.
The topic was also very nice. My question is, you have been told to use a BERT model, right?
Yeah.
How exactly it has been working with this system?
In this system.
Yeah.
Yeah. So when user inputs a question, we can't directly process the English words itself. So we need
Yes.
to convert these words after pre-processing into vector embeddings in order to compare the similarity.
Yes.
Yeah, there will be using sentence BERT to convert into vector embed.
Okay, fine. And you have been given with the accuracy 80% something, right?
Yeah.
With your this process of like BM25, then K-means and then text rank which you have been used, and you have been told you are created with the clusters. So, like how much of the clusters you have been created?
So the number of clusters right now are 4 because this needs to be experimented with. The data set which we had right now, and according to the questions, 4 seemed to be working the best. But we might need to change accordingly.
Yes, so
That
because
was one of the limitations in our paper.
yeah, you are given accuracy is 80%. I thought that you should try with some other models also so that it can get increased with the accuracy of your system also, right?
Yeah,
Yeah, that's it. That very nice. Thank you.
thank you.
Thank you so much. Moving forward, I would like to invite Kalpana Naidu to kindly present her paper titled Penalty-Based Optimization for Power Allocation in UAV-Assisted Relay Networks. Do we have you here with us, Kalpana?
Yeah, actually, I'm Sachit Anand. I'm the
Okay.
co-author and I'll present. Can you hear me? Is my voice fine?
Yes. Your voice is audible. You may present now.
Okay, sure. Guys, my screen visible?
Yes. Wait, no.
Okay.
Yes, your screen is visible now. You may start.
Yeah. So, hello everyone. Good morning, good afternoon, and good evening. So, our work is penalty-based optimization for power allocation in UAV assisted relay networks, ensuring SNR distance constraints while maximizing data rates. And I have done this work with my professor Kalpana Naidu. One second. Yeah. So, coming to our idea. So we know that UAVs are battery powered and they have several limitations in terms of providing communication service. So our goal was to um, like get achieve a significant data throughput with the limited resources that the UAV has, like power, uh, uh, let's say uh, distance issues like users can be very far away and etc. And also ensuring it's not just about data throughput, it's on also ensuring uh, error-free communication by having some high SNR, and also ensuring fairness to all users, that all users get at least a minimum amount of data rate for basic communication. Coming to the literacy survey, um, we have looked into like previous works with similar ideas. So one is fast computation of generalized water filling problems. Uh, what this exactly does is it uses water filling algorithm to allocate resources under certain power constraints. And one more is resource allocation and UAV's placement in cell-free wireless networks. This paper presents heuristic and PSO-based algorithms, which is mainly focused on improving QoS, quality of service. And the next one is practical algorithms for a family of water filling solutions. This is actually a more mathematical paper in which water filling algorithm is improved, uh, and multiple water levels are used to solve a wide range of problems. And the last one is minimizing energy consumption in a NOMA based UAV assisted MBC network. So this paper uses NOMA and OMA approaches to optimize energy consumption. Now this is the system flow. So in our system there is a static UAV which takes a, signal from the base station and provide the signal to the end users. They can be like mobile phones, laptops, and anything. So like the system is used in places where mobile tower can't be established. Let's say some faraway mountain. Drone can easily go near the mountain, but a mobile tower can't be like set up there. So our aim is to like provide good signal to the faraway users. So first we initialize the user distances, like each user distance from the UAV, and calculate channel gains using path loss model. And then here we use something called power allocation matrix. And also in this project, what we did is we're not only just considering the users itself, even users have various subcarriers, like especially in OFDM communication. So we are considering that also for each subcarrier, how much power is being allocated. That is determined by power allocation matrix, where users are denoted by rows and the users subcarrier is denoted by column. And then we are using an iterative approach for this, in which first the like SNRs are computed, total power utilized is computed, distance power products are computed, and even data rate is computed. So we'll check if all the constraints are satisfied. Here, constraints means the limited resources that UAV has. And if they are not satisfied, then we use the penalty-based water filling approach, and then and then again do the required adjustments and see if constraints are satisfied or not. Till they're satisfied, is the like our algorithm keeps iterating, and once they're satisfied, and also once convergence is achieved, it's not just about being satisfied, we need even high data rate, not just satisfying the constraints. So till the convergence point is achieved, this algorithm keeps iterating, and after that we even visualize the results, get the power allocation matrix, power heat map, etc., which we will see later. So coming to our workflow, we can divide our workflow into 3 stages. Stage 1 is initialization. First, we need to be clear, like how many users are there, how many subcarriers are there for each user or subchannels, and what is the noise are we thinking about. We are considering here AWGN, additive white Gaussian noise. And then after that, and like in our simulation, we chose 4 users, and each user having 3 subcarriers, and the rest of them are constants. And after this, this is the main part. Like these are the constraints or the limitations of the UAV. Since UAV is battery powered, it only possesses a limited amount of power. So we should make sure that the power allocated to each user via UAV should be like the sum of them should be lesser than the maximum power, and also SNR threshold. So the sum of SNRs achieved by each user should be greater than some threshold, because to ensure error-free communication. Distance power constraint. This is a unique thing in our paper. So we thought, like in the previous works, it was like it was only about power allocation. But here, it so happened that with those algorithms, sometimes the, let's say, faraway user gets very less power, very less importance, so that they cannot even communicate properly. Even basic communication is not possible. So we wanted to ensure fairness in this. So let's say this is like the distance of that user and the power allocated to that user multiplication should be lesser than distance power max. It means that so what it actually says that even, let's say that the nearer users shouldn't get very high power. They should, so because if nearby users get very high power, the far away users get very low power. That it shouldn't be like that. And the distance, and it should be greater than the distance power min. What it exactly says is the far away users should get at least some limited amount of power to ensure basic communication. So one more constraint is non-negativity. So like each and every power should always be greater than or equal to 0. This is like there to check that algorithm should not like sometimes when these math algorithms are running, they go to even negative. So that should not happen. That's why we introduce that. Stage 2 is the main algorithm, iterative water filling power adjustment. So in our algorithm, what actually happens is the powers are dynamically allocated, and constraint satisfaction is checked every time, and penalty based refinement happens. Like if there is any deviation, the powers are penalized, and then convergence iteration continue till data rate convergence, data transfer convergence. So we are using Shannon capacity theorem formula to calculate the data throughput. And this convergence check actually happens on the data throughput, because like the one of the main parameters in communication is to achieve good data throughput, and our focus is on that. And after that, output results are displayed. So now what is the work that we have done? First, we have to initialize the system and sub channels for each user. Then we have to calculate channel gain using path loss model. And yeah, this is the main thing. So first, what we do is, let's say if constraints are not satisfied, the iteration begins, and then if constraints are not satisfied, a term called penalty term is calculated. This is the penalty term, and after that, this penalty term is used to calculate some other term called correction term. This is W. This is the water filling equation, and then after that, power is allocated in this way: W, comma, it's either the minimum of the W or P max by N into Xi. So actually what happens is, initially when we're beginning the algorithm, we allocate equal power to all. So all the subcarriers. So which is P max by N into Xi. So
This is a gentle 1 minute reminder.
oh, okay. Okay, sorry, I'll finish it quickly. So one more is a distance power constraint adjustment. So a distance power constraint, if it is not satisfied, it is adjusted in using this equation, and this normalization is done to satisfy the power budget. So these are the results we obtained. We are able to achieve 58 Mbps, and SNR we got well above the threshold, and fairly that the power also is allocated fairly, and this is the result for every 10th iteration. this is the graph where for every iteration the data rate is increasing till here. After this convergence point, the data rate will decrease. So this is the best we could achieve in 493 iterations. This is the power heat map, which is the power is fairly distributed to all the subcarriers, and each and every user is able to get between 12 to 15 Mbps according to this graph. And I would like to conclude my work, and also I would like to tell that the unique thing about our work is like in the previous works, let's say only one constraint is specifically focused, like SNR constraint or distance, power, etc. But here we solve multiple constraints, and also we combine penalty and water filling approaches. In the previous works, penalty is different. And try to combine all of them to get better used.
Thank you,
Okay,
Sachin.
thank you.
Thank
Any
you.
questions?
Nice presentation.
Okay. Sorry if I
Uh,
took a little more time.
tell me, Sachit,
Yeah.
why dynamic power allocation important in your work?
Because one thing is this users keep moving, and it is like users don't stay at the same place. So once user might be far away, once user might be near. So accordingly, power should be allocated.
Why you specially choose a penalty-based approach for this problem?
Because actually in the previous works only water filling is done, but when we tried only, but we thought, like in previous works, it was like there was power constraint and water filling is done. But now we are as we are adding more constraints, so only water filling was not helping. So we thought we would even add another constant called penalty constant, which is calculated by the equation mentioned in the PPT, to as an addition to the water filling approach, so that we can get better result with it.
How this method, your penalty method, handle constraints?
Sorry, penalty method handling constraints.
Yeah.
Okay. So what happens is actually this penalty method is used to calculate powers. So let's say once constraints are not satisfied, this penalty method first to calculate powers, and and also those powers are further refined with other equations that are mentioned. Like if distance power constraint is not satisfied, one equation they get updated one equation, and if total power is not satisfied, the normalization is done. So it is not just the penalty that is solving the constraints. The things are the equations after the penalty and water filling are the one that are actually like trying to solve the constraints.
What optimization algorithm you use?
Water filling.
Okay. Can UAV help enhance throughput or not?
You can UAV enhance means actually it actually takes signal from base station. So obviously it won't be able to convert it the output. It won't can 100% give the output because there will be some loss, and UAV also has very limited resources. So like with limited power. So but it will, our aim is to like get the best out of the limited resources that we have for the UAV.
What parameter you use for your simulation?
What parameter for
Simulation.
simulation? Like we use the data rate as our main priority to improve.
Okay. Okay. Nice. Thank you.
Yeah, and also it should not exceed the power. It should, like what we thought was like we have some power budget. It should go till the we had 3 watts till
Any idea?
2.99 we were able to achieve. Yeah.
Any idea about UAV altitude?
Altitude we haven't considered that as of now. We just
Okay.
calculate distance from each user,
Only
like
checking
direct
power
line of sight
limits.
distance.
Okay. Thank you.
Okay. Thank you.
Yeah, hello. Nice presentation, Sachin.
Okay, thank you.
My one question is there. Can
Yeah.
it be possible if
Mhm.
we integrate penalty-based optimization with machine learning-based prediction of like in this UAV network? Has it been possible?
It's definitely worth a try because many other works use machine learning approaches also. Like some even use reinforcement learning approaches. So It would be a great addition actually. I mean that like
Okay.
that would improve, I think, for sure.
Yeah, that's it. That is from my side only. Thank you.
Okay, thank you.
Thank you. Thank you, Sachin. Thank you, Farhan ma'am. Just a second. Moving forward, I would like to invite Krish Soni to kindly present his paper titled Predicting Car Prices Using Machine Learning by Assessing the Performance of Linear and Non-Linear Models. Do we have you here with us, Krish? Are any of the team members present? All right, since no one is responding, I'll be moving forward. I invite Madira Sai to kindly present her paper titled Real-Time Sign Language Recognition, a Model Comparison Using MobileNet V2, VGG16, and FNN. Do we have you here with us?
Yes, ma'am. Yes.
All right, I'll stop presenting so that you can share your screen. Yes, your screen is visible. You may
Is
start.
it visible, ma'am?
Yes, it's visible. You may start.
Okay. First of all, good afternoon to everyone present in this conference. I am Madhira Sai Rishita, and today I'll be presenting our paper titled Real-Time Sign Language Recognition, a model comparison using MobileNet V2, VGG16, FNN. Authors are Madhira Sai Rishita, Kamala, Hasini, and Rashmika. We are from CMR College of Engineering and Technology. Introduction. Sign language is a vital mode of communication for deaf and hard hearing community as well as non-speaking individuals. However, existing solutions lack efficiency, real-time adaptability, and accessibility. To address this gap, we have developed real-time sign language detection web application, which provides an effective and user-friendly solution. This app translates sign language hand movements into written text and spoken words, making communication more inclusive and accessible. Our project leverages deep learning and computer vision to analyze hand gestures using MediaPipe for real-time hand tracking and gesture recognition. So the next is research objective. The focus of our research was to address key challenges in real-time sign language detection. The first one is awareness, public awareness, the cost barriers uh, for interpreters. We analyze existing platforms, identify gaps in speed, reliability, and usability. In response to this, our solution integrates MediaPipe with deep learning models for offering accurate real-time gesture recognition through intuitive and accessible interface. The problem statement. Communication barriers between hearing impaired individuals and general populations is challenges for day-to-day interactions, education, and employment. Existing sign language systems offer lack accuracy, struggle with real-time recognition, and not accessible due to high computational or financial requirements. There is a critical need for robust and efficient, affordable solution. So this is the scope of our project. The primary goal of the project is to build robust system facilitating seamless real-time communication for naturally and confidently in the daily life to interact with daily life. So the data set used is American Sign Language. It has 36 classes. The data set is combined of alphabets and digits, alphabets A to Z and digits 0 to 9. As you can see, these are the gestures in American Sign Language. So we have used Kaggle dataset. We have combined two different datasets. One is alphabets and digits. You can see it here. This is the architecture of our proposed solution. We have used different deep learning models, mobile VNet, EfficientNet, and FNN plus MediaPipe. So first thing is video acquisition. Here, whenever the gesture is presented in webcam, it extracts the 21 landmarks and sent to the pre-processing. In pre-processing, where data augmentation is done, it is pre-sized and features are taken out, and here the feature extraction is done. And here we leverage a deep learning model, and detection is done, and result is seen. So first thing, since there are different deep learning models, so first thing we do is data processing is done for our Kaggle data set. We use raw images for FNN. We use landmarks where landmarks are extracted and converted into .npy file, and that landmarks are used for detection. So first one is efficient net B0. Here, while when we were improving the model, there was no improvement in our epoch, so it was stagnant. So we had to stop it in between because the model is a lightweight model. It was having improper hyperparameters, so it was not efficient to continue with efficient net B0. The second one is VGG16. Here we have acquired 86% of accuracy, test accuracy. It was better for compared to the efficient net for static image, but it did struggle in real time for hand positions because there are many similarities in the hand position between alphabets and digits. The model would be a benefit from temporal information integration data augmentation techniques to improve real-time recognition. The third one is MobileNet V2. Here, this is the best model in CNN deep learning, which we have acquired 97% test accuracy. But during the real-time accuracy, it achieved only 82% because it was always confusing with the letters with a V and W, 2 and 3, 5 and B, because they all are similar gestures. Only the alpha one thumb movement is different. So it also needs the pre-processing, better pre-processing for potential model combinations for enhancing world robustness. So this is our main best model, that is FNN, feed forward neural network with media pipe. The first thing is data collection. As I said, 21 landmarks are taken. So we take X, Y, Z coordinates and of the landmarks, and we get it with 126 shape. So next thing is pre-processing it. We pre-process the data into batch normalization. We also mirror the X coordinates to increase the data set size. So for the better prediction, the next feature extraction is done. Here the data set which we have custom data set we have taken. We divided it into train data set and test data set. Next, the model is revised. We find the accuracy and predicted result sign is detection. So here in this particular model, we have acquired 98.96 accuracy, and in the real time, it is only 90%. For example, if you are taking a sentence which consists of 10 characters in it, excluding space in it, in that 9 characters are predicted correctly. So compared to other CNN models, it has the better accuracy, but still it also faces challenges for different shape similarities. For M, and M is always misclassified as N, and for 5 and B it is confused, but it is not the same for every prediction. It also robust against light variation, motion blur, and slight misclassifications occur. So this is our workflow. First thing, we sign a gesture in the front of webcam. Data processing is done. 21 landmarks are extracted and it is given to deep learning model. Then sign is detected. It is converted to sign to text using Google Translator and text to speech using Google text to speech, and it is represented on the web interface. This is our results. As you can see here, I have different background in the first image and different background in the second images, and the light, there is also light variation, and but FNN plus media pipe model works better than the other models. Here you can see detected sentence word is high, and we have translated here to namaste in Hindi. We can also translate it to other Telugu or any regional languages of India. Here I've tried to create a sentence, bag and you. Here we have different buttons which helps us to start, stop, or restart our model, and add space for if there is any ambiguity while detecting. Here we can use the clear last letter, and this translate button is used to translate it to another regional languages. So this is our model's results presented in a table. the strengths and weaknesses are also given. Based on our findings for FNN plus media pipe model, the speed of the inference speed was better compared to the other CNN model. So we chose FNN media pipe as the best model for our project. So this is the comparison of our results. In conclusion, I conclude that our proposed system bridges the communication gap for the hearing impaired by providing an accurate real-time sign language detection platform. By leveraging deep learning models in MediaPipe, we can also have future scope of making that into a hybrid model using MobileNet and MediaPipe, and also for use it for custom data set and create an enhanced pre-processing. These are the references. Thank you.
Thank you so much, Rishita.
Nice presentation, huh?
Thank you, sir.
Tell me, why you specially choose sign language recognition?
Uh, I had an interest on learning sign language, sir. So
Okay.
that is how I wanted to do something regarding it. And my teammates and my guide, Kamla ma'am, also encouraged to work on the real-time problems. So I chose the real-time sign language.
Then how you split your data set?
I split the data set into 80% for training and 20% for testing, sir, for my custom data set. But for the before MobileNet and all, I used for CNN deep learning, I've used Kaggle dataset. Since it was a large dataset, I wanted to test on more dataset. So it was divided on 70% and 30%.
What are the advantages of VGG16?
In this VGG16 achieved a good percentage, sir, but it was lacking the speed inference. It was taking a lot of time to predict the gesture. So we had to go to other one. Though the prediction was right in real time, it was having difficulties in misclassification.
Any limitation of your put it? Any
Uh,
limitation?
yeah, sir. As I mentioned earlier, the limitation is misclassification of M and N. So since the gesture is very similar, most frequently I'm finding M and N are misclassified. So we are actually working on improving the data set for better prediction and better pre-processing and data augmentation can also be improved, sir.
Okay, from my side. Thank you.
Hello. Nice presentation.
Thank you,
Uh,
ma'am.
yeah, my question is that when you have been showing with your gestures through your camera, the background
Yes.
images and all that will be how it has been handling that particular thing?
Uh, the FNN
Since
media
it
type is irrelevant, ma'am. For the FNN model, the background is not creating any disturbance, ma'am. That is the reason I have showed the different backgrounds in it,
okay.
because it is using
And
landmarks of the hands, the 21 landmarks. That is the
mm,
reason it is not using. For the other models, we had to use the raw images for the in the data set. So we found difficulty for the lighting and background images. Since it is landmarks, it is working better than the other ones.
okay. And out of your these three models which are given, VGG, MobileNet, and FNN,
Yes, ma'am.
you're getting the better accuracy with FNN, right?
Yes, ma'am.
Yeah. Have you been tried for like making hybrid of it, or again trying for better accuracy, again better than this?
Yes, ma'am.
Like
I am actually working on it and as a future enhancement in it for better one, FNN plus MobileNet and other models also. I'm trying to work on it. I will definitely try to improve the accuracy.
yeah, okay, fine. And one more is there. This is like text to speech you have been giving, right? Or speech to
Yes,
speech?
ma'am.
Only text to speech?
Text to speech, ma'am, and also voice, spoken words was also given, ma'am.
Okay, okay, fine. Thank you. Thank you.
Okay.
Thank you so much, Ruchita. Thank you, ma'am. Moving forward, I would like to invite Jeffrey Ryan to kindly present his paper titled Soul Care, a privacy-focused, locally run AI chatbot for supporting mental health. Do we have you here with us, Jeffrey?
Yeah, I'll present the screen.
All right, please go ahead.
Okay, I hope it is visible.
Yes, it's visible.
Okay, so I'm Jeffrey from Karnataka University, India. I'm currently working as LLM trainer for Google DeepMind and Microsoft training their LLMs. So now I'll be introducing you to my paper titled The Soul Care, a privacy-focused locally run AI chatbot for supporting mental health. Uh, so the co-authors of this paper is Dr. Emmanuel Joy and Dr. Sugandhi Evangeline and Dr. Janessa Roma. So we'll go with the overview. Now we have seen there's exponential growth in the AI, and so many industries and communities are training AI to solve different problems. Also, if you see in mental health, there are so many AI solutions are there, even for mental health or for other for even surgeries. So many AI solutions are there. So for this project, I'm specifically focusing for mental health. So, because of this exponential growth in AI, I chose to address this mental health problem. So, my main motive of this project is to prove that AI can be used to address mental health or other health problems without compromising security and privacy and usability. That's the main motive of this project. So now I'll tell you why I chose this. So currently, for the mental health, if you see, currently we are having data privacy. Like there are chat GPTs are there, Gemini, DeepSeek, so many AI chatbots are there. We can ask for mental health, but we also worry about our conversations. What if whatever we are conversing with a chatbot, what if the company or other people uses our conversations and give targeted ads or some kind of things? What if they do other than what we intended for? That's the worry currently. And also, if you see, I'll give an example. 2 to 3 months back, DeepSeek was introduced. So in that initial period, so many users went there and used DeepSeek because it is new and free. Like nearly a million users used, and within 2 to 3 days, hackers hacked DeepSeek and hacked all the conversations from the users. So that's what the data privacy is the issue now. Also, if you see in the current mental health scenario, it's limited access. So if the people are living in rural areas and they don't have the hospitals nearby for accessing this mental health, they have to travel far distance. So that's limited access. Also, if we go to the hospital, we have to wait for long wait times. So that's delayed assistance. And also, even with the DeepSeek and ChatGPT, it is all depend on the internet. So we have to pay for the internet to use it. So it's less accessible for all the people. So Soulcare addresses this. In Soulcare, what I'm doing is I'm creating a solution that runs. It's a product based on LLM that runs in user's device locally. It doesn't need any internet. Once you download the product, that's it. It's free. You will be running the product in your laptop. It will be locally executed, so it will be available anywhere, anytime, offline functional. So you don't need to worry about your conversations where it will be stored, because we are not using any cloud services like GCP, Azure. It is all in your hard disk or SSD. So you will be having full control of it. Also, it is you won't have any long wait times. There won't be delayed assistance. It's instant response. Whenever you want, you can chat with it. Now we'll unveil the code. Um, this is the architecture of the Soulcare. We'll be having web app implemented Streamlit, and the backend is powered with Fast API. So First, the user will be interacting with the Streamlit web, and that query will be sent to the FastAPI server, and FastAPI server sends that to the fine-tuned LLM, and LLM sends the response, and FastAPI gives the response to the Streamlit, the website, and user sees it. This is the overall architecture of it. To the front end, as I said, we are using Streamlit. It's very easy to build, even for us developers, also for users, because it's very minimalist interface. Also in Streamlit, I provided two features. It gives chat history, so that whatever user chats with the Soulcare, it all stored in the session, so user can easily see what previously they spoke with the Soulcare and what advice they got. Also, if they feel insecure about the conversations, they can easily click clear chat history, so it will be deleted forever. It won't be it won't be stored anywhere. It's deleted. So that's why it's truly private, locally run chatbot. On the backend, I'm using FastAPI for efficient inference. It's a bridge between the Streamlit, the front end, and the fine-tuned LLM. It's a bridge. It just gets the request, transfer to the LLM, and gets the response from the LLM and gives that to the user. And the fine-tuned LLM. This is the main part. This is the heart of this project. So we are using Gemma 2B model. There are other LLMs. You see Meta's Llama 3, Llama 2, and even Gemma 3. When I did this project, at that time it was we had only Gemma 2B, Gemma 2 and 2B, and Llama 2. That's what we had. Also, I checked with all the other models, and Gemma 2B outperformed all those models. So I chose this. Also, this is a lightweight model. This Gemma 2B model original size is around 4 GB. Also, this whole LLM runs only in GPU. So usually we have 2 GB GPU and 4 GB GPU. Normal user won't have 16 GB or 32 GB GPUs in their PCs. So I was focusing especially for the lightweight models. So I chose this Gemma 2B, and I fine-tuned this Gemma 2B for stress, anxiety, emotional support. I got this dataset from multiple Hugging Face repos and aggregated all the dataset and pre-processed it. Totally after aggregation, the dataset is around 44,000 samples. So I followed the 80-20 procedure. So 80% used for training. So it came around 35,000 samples for training and 9,000 for testing. So training process used PyTorch and Hugging Face transformers. So this is a procedure. But the twist here is I'm not directly using Gemma 2B that Google produced. I'm using Gemma from Unsloth because, as I said, Gemma's original size is around 4 GB. So if you want to train the 4 GB, you need to have 2 times of that GB. So I need to have 8 GB or 10 GB GPU memory to train this Gemma 2B. So it's not feasible. So I have to quantize this Gemma 2B to reduce the size. Quantization is the process of reducing the model size to lesser. So initially Gemma 2B will be having its weights around like float 32 or float 16. It will be having the weight precision is like that. But I have to reduce the precision to like float instead of not even float, int 8, int 4, int 3. Likewise, I have to reduce the weight of it. So even for reducing it, I need to have a 10 GB, 12 GB GPU. So Unsloth, it's a very good community. They are producing this Gemma 2B. They quantize it for you, and they will put that in their repo. We can just download the quantized version of it. So that saves a lot of time. So I use Unsloth to download the 4-bit Gemma 2B model. And then I use the PEFT is the parameter efficient fine tuning. Normally in deep learning and machine learning, what we do is we train all the weights present in that deep neural networks. But using in LLM, it's all very large, deeply connected neural network using transformer architecture. In that, we can't train each and every weight vector, right? For example, as I said, 2B, gamma 2B, 2 billion parameters it is having. 2 billion weights we have to train. So it's completely invisible. So what we have to use is we have to parameter efficient fine tuning. What it does is it checks it efficiently selects which weight we have to modify so that it gets fine tuned fast instead of
This is a gentle
optimizing.
1 minute reminder.
Yeah, sure. Within 1 minute I complete. So that's why we use PIFT, and I use a system prompt to steer the responses and for fine tuning, and I use a safety trainer. It's a part of transformer. I set all the learning rate and optimizer and schedule learning folks, everything. And I train the LLM for 4,000 steps. And after training, we'll be having the weights, the LoRa adapters, we say. That's the weight, that's the result of the training. And using that weight, we again merge with the original Gamma 2B, not quantize, it's the original Gamma 2B. We'll just merge the weights with that. So we'll save that model. So this board had this is the first image, the gradient normalization. Initially, it is around 3, and it drops to 0.5, 0.25, and then it raises up to 1.5 at 4,000 steps. So we can see the grad norm, based on grad norm, the model is converging. And also train loss, initially it is around 2.5 and it fell down at 1. And if you see in the 4,000 step, it's like a plateau, very, very small fluctuation. So it converged very well. Also for deployment, we save that merged model to the Hugging Face.
I'm
So
sorry, I
after,
would have to cut. Can you please wrap up the presentation? You have crossed the time.
okay. So after that, uh, uh, we deployed in Hugging Face. So this is the perform evaluation. The left is a fine-tuned metric, and the original, you can see how our fine-tuned outperformed the baseline gamma model. Even answer relevancy, everything. Bias, we completely remove the 0% bias we're having. So this is how the whole carries. So in future, I'm focusing for providing multilingual support and emotion detection, and even thinking of providing the Soulcare in a app so that user can easily download in their mobile through Play Store or App Store. And that's it. Thank you.
Nice presentation, Jeffrey.
Thank you.
Tell me, is your model understand emotion?
Yeah, currently it understands emotion, but it's as I said, it's a 2B, so it's not that intelligent like ChatGPT. ChatGPT is like 2.5 trillion parameters model. So 2 billion parameters, it is not that much knowledge. It's not that much smarter like ChatGPT. So it understands emotion, but not in a smarter way. So yeah, I'm investigating other procedures to handle it.
Any ethical consideration in your mind?
Ethical considerations.
Yeah.
So for this model, after training, I ran with a deep eval framework provided by Confident AI to check whether how the model is performing. So the metrics here, this is all got from deep eval. Deep eval have an internal data set which we can't see, but we can just test the model with that. So people gave the sociology under sociology how the model is performing, under humanism, under professional psychology. Professional psychology have so many MCQs related to psychology, and also under moral discourse how the model is performing, under public relation. So in bias, when the prompt is given with racial or political or gender bias, how the model is tackling that. So answer relevancy, everything the deep web framework evaluates the LLM for us and gives us accuracy. And in that, if you see even the bias, it's 0%. There's no gender ethical bias. Nothing is there in the fine tune.
Is your model contribute to mental health awareness?
Yeah, that's the main focus of this.
Or tell me, is your model replace a therapist?
It won't replace the therapist. And that's not the motive of this. For the people who are having problems with accessing mental health, or for the people who are feeling insecure about the conversations, For that, I'm using it won't completely replace even in the model. If you see it, sometimes it will tell to reach out therapist for additional support. Likewise, only my model will give. It won't completely replace. Also, you have to note it's 2 billion model, so it's not that knowledgeable to replace a therapist.
It be used in the real life?
What?
Can it be used in the real life?
Yeah,
Real
we
life.
can use it. Yeah, we can use it. It's not a prototype. It's a product now. So you can download from the repo and you can use it.
Any limitation?
So far, no limitations, except this 2 billion parameters. If they are using 100 or 120 billion or 70, at least 60 billion parameters, then it will be even more smarter. So that's the limitation we are having. It's all the limitations due to the user CPU. If the user CPU is having 2 GB or 3 GB GPU, then they can't run a 70 billion parameter. If they are having 32 or 64 GB GPU, they can easily run a 60 or 120 billion parameter. The limitation is the user's end device.
Okay. Thank you.
Thank you.
Hello, Jeffy, nice presentation.
Thank you.
My question is how it has been handling with the data privacy?
Data privacy. Once the user downloads the software, he won't be again connected with the internet. The model itself, it's all LLM. Everything is local. All the servers, even the Streamlit server and the Fast API server, everything will run in the user's device. So there won't be any data will be sent to any cloud or anything. So all the conversations, it will be stored in the user device. Also, when you start the server, the Streamlit server, the session will be created with LLM. You will be speaking with LLM. But once you exit the session, automatically the conversations will be deleted. It won't be stored anywhere, like even in a SQL database. Even in the session itself, or we have provided a option to clear chat history. While running in the session itself, you can clear. Also, after session, automatically by default, it will clear the chat. That's how. That's what the privacy we are giving here.
Oh, means I will able to clear the history. So no any cookies or sessions will be created for this.
Whatever model consumed while running the session, all the data related to it, everything will be cleared. Whatever model created, even for temporary files, everything will be cleared after the end the session. There won't be a trace of
Fine.
it.
Fine. One more question is there, like it is completely you are saying offline chatbot. So
Yeah.
like how can the natural language understanding or like we can say sentiment analysis can be optimized here in this offline chatbot?
Yeah. For all the NLP, we are using LLM. So LLM, we know ChatGPT, right? Basically, it understands the context and it responds to the user.
But
ChatGPT is using GPT LLM. That's what
yeah,
like I'm using Gemma LLM provided by Google.
yeah, but it is offline chatbot, right? Locally you have said.
Yeah.
So locally, is it been possible to handle all the sentiment analysis? Means mental therapy, no? This is health related issue, right? So it is very big kind of a thing, mental health and all that. So the sentiments are very much important in this. So that's why I'm asking you how it has been optimized for better performance. That's it.
So we got 44,000 samples from mental health repositories.
Hmm.
So based on that, we trained, and the model also it won't be like it won't give a direct or complete answer. So for
Yeah.
example, if you see uh, in the top right, and the user is asking, "I'm overwhelmed with the workload. How can I manage stress?" And it is responding. It is important to prioritize. Okay. It is important to
Hmm.
prioritize the task and break them down into smaller,
Hmm.
manageable steps. Additionally, practicing relaxation techniques such as deep breathing can help reduce stress
Hmm.
levels. Likewise, it is not like how a therapist gives. It is more general, right? So that's why that's what 2B model gives. we can't directly rely on it. Also, sometimes model itself tells you, I can't handle this. You have to directly have a consultation with the therapist. That's how the model responds.
Okay, fine. You have been using with Gamma 2B, right? So have you
Yeah, Gamma
compared
2.
some other LLMs also? Other kind
Yeah,
of
I tested other even Meta's Llama 2. Um, it worked well, but my system, I'm having 4 GB GPU. But when I run with
oh,
Llama, the 2B, it didn't perform well. Also, it demanded more GPU RAM. Um,
mm,
4 GB is not enough for it. It asks for 6 or 7 GB GPU. This Gamma
okay,
2B only satisfied with the 4 GB GPU.
fine,
So
fine.
that's why
So
I
that
can.
can be one limitation we can say, right?
Yeah. The only the limitation is the end user's device. If the end user
Okay,
device is having 16 or 32, they can run more advanced LLM.
yeah,
I guess
okay.
in
Nice.
future we'll be having more higher GB GPUs. Even NVIDIA now provides a 5080 with lesser cost than 4090. So in future
Oh,
we'll expect, yeah.
yeah, okay. Okay, okay. Thank you. Nice.
Thank you.
Thank you so much. Moving forward, I would like to invite Vadi Rishika to kindly present her paper titled Tracking Deforestation Through Satellite Imagery, a fusion of hybrid classification and clustering approach. Do we have you here with us, Rishika?
Yes, ma'am.
All right, I'll stop sharing the screen. Yes, you may share your screen now.
Is it visible, ma'am?
Yes, it's visible. You may start.
Okay. So good morning or afternoon, everyone. Myself, I'm Vadi Rishika, and I'm happy to present at the 9th International Conference on Information and Communication Technology for Intelligent Systems. Today, I'll be presenting our project titled Tracking Deforestation Through Satellite Imagery, a fusion of hybrid classification and clustering approach. And this is implemented under the guidance of VA Narayana, sir. Okay, 1 minute.
You are not audible.
Yeah.
Yeah, okay.
So, first thing is, this all deals about regarding the loss of forest and deforestation. So the first thing is loss of habitat and biodiversity. So we know forests are home to millions of species. When we clear forest, we destroy their natural habits, or else, like causing a decline in biodiversity and their whole ecosystem. The next one is a deep impact on climate change. That is, forest acts as a carbon sink, absorbing CO2, and also it stores carbon, which releases back into the atmosphere. Everything causes an impact on climate change. And the next thing is soil erosion and land degradation. Without trees, we know soil gets exposed to different chemicals, and also it leads to soil erosion. The next one is it even affects on indigenous communities, like people who depend on forest and who take their shelter in the forest. They get affected drastically because of this deforestation and cut down of all the trees. And the last and the important one is the economic and resource loss. So forests provide essential resources like timber and medical plants. Due to the destruction of all the trees, it not only impacts the local economic, but also it has a global economic consequences. And these are our research objectives, like to develop an accurate detection system using the ML or deep learning models, track the forest cover change, like how much the area was cleared, and what is the measurement of the area, to integrate multi-source data, and also to evaluate environmental impact, like to get to know how much area got deforested or what is the impact, how much it is getting impacted on the climate, all these things. And the next one is problem statement. So here we have total 5 things. First one is threats of deforestation. So
Deforestation endangers biodiversity. It also affects climate stability and threatens sustainable development. Limitations of traditional monitoring. We have different traditional systems detecting the deforestation or else land clearance. So the limitations are like existing deforestation monitoring systems are slow and imprecise, like causing delays in taking action or else less detection accuracy, all those things. The main project objective is to utilize or leverage AI and satellite imagery to create an accurate, scalable deforestation detection model, and also to create a real-time visualization platform for user-friendly purpose to end users. And the scope of the project is using the satellite images, making use of deep learning and machine learning models like UNet, ResNet, ResNet 50, MobileNet, Inception V3, and again creating a real-time monitoring platform using Streamlit for the front-end part. So here comes the proposed methodology. So first, we input a satellite image, which goes for the binary classification. That is, the particular image gets classified as afforested or deforested image. If it is classified as deforested image, then it goes for semantic segmentation. That is, calculating the area, like how much land got cleared in that particular image. We calculate the deforested area, then we evaluate pre-trained models, we analyze the model performance. If anything need to be optimized or enhanced with the model's weights and inputs, we can fine tune like that. That can be done. And at last, we integrate into a web application, which is on Streamlit, and deliver the results to the end users. So the experimental status is like fused to two data sets, which contains of 5,000 satellite images and 6,000 satellite images. But the one I chose is the 5,000 satellite images. So here I've experimented on different deep learning models like ResNet, EfficientNet, Inception V3, MobileNet, and VGG16. So these were the models which have been experimented using that particular data set. And the observations were for MobileNet it was lightweight and efficient. For EfficientNet, it was balanced and was getting a good accuracy. For Inception V3, it could capture all the complex patterns and the features in the satellite images. For VGG16, it was good for overfitting. I mean, it got overcome the challenges of the overfitting due to the consideration of small data set. And ResNet here is the one which got the less accuracy because of the constraints and other parameters. So the novelty we've explored and raised is the hybrid model implementation with the model which has got the less accuracy, that is the ResNet. So hybrid model implementation is like combining another model, ML model or deep learning model with the with the used ResNet model. That is, firstly, we've got ResNet model around 57 to 60% of the accuracy, which is the least one. So the main aim of our project was to improve this accuracy by combining it with some other deep learning or machine learning model, and making it as a hybrid model implementation. So the other machine learning model we've considered is support vector machine. So this is a combination of ResNet 50 and support vector machines. Here we can see the confusion matrix for ResNet 50 and ResNet 50 plus SVM. There's a huge difference. Like for actual afforestation detection, it got only 220 images like that, correct? But when we implemented with this hybrid model, we got around 400 images correct. And we can just see the false negative part, that is 89 and 94, which is being the least, and the correct detections, that is 400 and 436 being the more. This shows the effectiveness of the hybrid model implementation. And here we can see the drastic increase from ResNet to ResNet plus SVM model usage, that is from 57 to 82%. This shows the novelty of our project, considering the least like, performed model and increasing it, improving it with other machine learning model. And the second part of the project is using k-means clustering approach for segmentation purpose. After classifying it as afforested or deforested images, whatever the deforested land is there, to detect and to calculate the area of the uh, all the cleared land, we use this k-means clustering approach, which is unsupervised learning, and we calculate the segmented area by taking the number of clusters. Here I've took 3 different clusters, and taking different deforested pixels and just converting them into calculating the Euclidean distance, and taking the cosine similarity, and just taking all these clusters, grouping them, and just calculating the area, how much effectively does it checks everything. So this is the results. This is our user interface. And
This will
yes,
be a 1 minute reminder.
so when we upload an image, here it clearly shows the images got classified as deforestation, and down it clearly calculates the area of the land which has got deforested. That is of 98%, and then the second image it got like some 85% around. And the next is I've uploaded few afforested, like full forest images, which has classified it as afforested. So the limitations for our project till now is there is no temporal change detection. That is, we only consider static images. There is no time-based analysis detection. So we can implement the multi-temporal satellite or Sentinel-2 datasets to analyze the timely and changes over the time. And the second one is it is just a limited data set. We've just created a foundation so that we can increase the data set size, and we can implement on more hybrid models, and we can check this. So by doing the data augmentation and transfer learning, we can increase the data set size. And this is the conclusion. We've used the ResNet and SVM to detect deforestation. And for future purpose, we can, yes, here I've used one machine learning and one deep learning model, but in future we can take a combination of 2 deep learning models, which are more powerful, and we can consider self-supervised learning, that is, without creating labels, the model itself creates the labels and classifies the images. So that is the future implementation, that is creating self-supervised learning and implementing 2 deep learning models as a hybrid model. So yes, these are the references, and yes, thank you.
Rishika, nice presentation, huh?
Thank you, sir.
Tell me, what features did you extract from the satellite image?
So the features extracted from the satellite images are the spatial dimensions, the size of the pixel, and also the quality, all those things from the particular image.
Why you specially use k-mean clustering?
K-means clustering is more effective, sir. We can create clusters, we can form clusters, like how many ever clusters we want. Like for now, in this, I've used 3 clusters to get effective results. But here we can have the customization of taking more number of clusters and get more precise area calculation. Basically, I've even implemented grayscale implementation also, sir, but that doesn't give me exact calculation. So that's the reason I've implemented the k-means clustering approach.
What library you use for image processing and modeling?
Huh?
Any library? Hello?
Hello.
Any library did you use?
Yes, we've used different libraries for like image processing, that is OpenCV, and for image rotation for augmentation purposes, we've used Pillow. We've even considered the scikit-learn library. So these are different libraries we've used. So TensorFlow, Keras for image generations.
How you evaluate model performance?
by taking the accuracy, confusion matrices, or else like, considering different performances matrices like F1 score, precision, recall, based on the confusion matrices we've got. From that, we can get the evaluation.
And, why you combine the classification and clustering both?
Uh, So the main aim was us to implement something, a combination of kind of things. Like classification should be a main theme, and then basically in existing systems, people either implemented classification or segmentation. But there is no uh, implementation which is combined, like classifying and then immediately calculating the area of the deforested land. So our main approach was to combine both the approaches and implement a model like that. Like all existing systems had different only classification or only segmentation, which is doing. That was our main approach.
Okay, from my side, thank you.
Thank you, sir.
Hello.
Hello, ma'am.
Nice presentation.
Thank you, ma'am.
My one question is there, like, has it been useful for identifying the early signs of forest degradation? Means
Ma'am?
forest early early forest degradation, early sign for the forest degradation.
Early
Is it
sign, yes, ma'am. We can do
uh,
this using the temporal. As I said, there is a limitation. Like we only use static images to early detect the degradation or deforestation. We can implement the climate change, like getting to know about different climate changes, and based on the weather climate changes, we can early detect the signs of deforestation in that particular forest or in that particular area, so that we can take the preventive measures accordingly.
okay? When
So as of
have
now, we are using static images. There is no sign to early detect early, but when we implement it using temporal analysis, we can get the early detection feature.
yeah, that is nice. Like for this purpose, like have you been talked about it with any forest department or anything?
As of now, I've just collected the data set from the websites or the government websites, ma'am. But directly contacting the forest officials or organizations, that I have
Like
not done yet.
like how those people are doing these things? Have you been
Many traditional methods were like taking the vegetation index or else calculating the burning ratio. Many organizations do in this way. But when we implement it using the temporal analysis, I guess that would be more effective than traditional methods which have been used now, like
yeah,
calculating the
nice,
vegetation index or based on burning ratios, like that.
nice. Can
Yeah.
you tell me your complete tech stack?
Tech stack has been, we've used Jupyter Notebook for the implementation purpose. We have used different libraries like OpenCV, Python, NumPy, and also TensorFlow, Keras, uh, for Scikit images for image processing, segmentation, all these things. And for front-end part, we've used a Streamlit interface to deploy it quickly. So yes,
Nice,
yes, ma'am.
nice. Thank you. Good.
Thank you, ma'am.
Thank you, Rishika. Moving forward, I would like to invite Dhruv Patel to kindly present his paper titled Understanding Textual Emotions by Evaluating NLP Model Performance. Do we have you here with us, Dhruv? Is anyone from the team present? All right, since no one is present, I'll just give a last call to the presenter who was not there earlier. Just a second. I invite Krish Soni to present his paper titled Predicting Car Prices Using Machine Learning by Assessing the Performance of Linear and Nonlinear Models. Are you here with us, Krish? Are any of the team members present? All right, since no one is responding, we'll be moving forward. Right. With this, we come to the end of this session. I sincerely thank all the authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 9th version and all the previous 8 versions of the conference. We will be happy to have you in the 10th version in 2026 as well. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to this printer. The publication will be live within 6 months. Kindly cooperate with the team of ICTIS 2025. I also thank our session chairs, Dr. Ajay Kumar Sharma and Professor Sarita Rathod, for sharing this session. Here's a small token of appreciation on behalf of ICTIS and Global Knowledge Research Foundation for our chairs. Just a second. Is my screen visible? Sorry.
Yes, ma'am.
All right. Yes, and with that, I just want to take a quick, if Ajay sir and Saida ma'am can share the closing remarks, how the session was, and just give us a feedback.
Hello,
Yes, sir.
I want to say something, Anna.
Yes, sir. Yes, sir.
I really appreciate the insightful work presented here. Most of the papers hold substantial potential for both academic level and real-world impact. Thank you for your presentations. And the depth of thought and technical rigor is very commendable. As far as suggestion is concerned, I would encourage you to further strengthen the credibility and practical relevance of your findings. Especially try to highlight the research gap your work is addressing. And again, thanks to organizer, technical members, core members, moderator, and especially thanks goes to Amit Joshi sir. Thank you.
Thank you. Thank you so much, sir. Sarita ma'am.
Yeah, thank you so much, Priyanshi ma'am. Uh, Special thank to all the organizers, uh, especially Amit sir, who has been invited me as a session chair to this, and I was able to get know about all the different topics the people are working, and all the topics are very nice. All the presenters has given very nice presentation. All the best to all of them. That too, like whatever the future scope they must be having, that they should work on it. Yeah, that is from my side. Thank you so much.
Thank you so much, ma'am.
Thank
Thank you so
thank
much. Thank you everyone for your valuable presence. I request you all, if you can just turn on your cameras for a quick snapshot, that will be great. Right. 1, 2, 3. Thank you so much. Thank you, everyone. Have a nice day. Bye-bye.
Thank you. Bye bye.
Bye.
Thank you. Thank you.